Okay, so we're here, section 1.2 AP Statistics, which is displaying quantitative data with graphs. So earlier we talked about displaying categorical data, and now we want to go into how we would display quantitative data, which is going to be data dealing with numbers only. So in section 1.2, you would want to, after we go through this and you do the work, you should be able to construct and interpret a dot plot, a stem plot, and a histogram. You should be able to describe the shape of a distribution, compare two distributions together, and use histograms as well. So let's start with dot plots. So a dot plot, each data value is shown as a dot above its location. So for instance, in this set, we're talking about the number of goals scored per game by the U.S. women's soccer team. And you can see there was only one game where they scored 0 goals. There were a large number of games, 1, 2, 3, 4, 5, 6, 7, 8, where they scored 1 goal. There were 6 games where they scored 2, and so on. You see one game they scored 6 goals, one game they scored 7 goals, and one game they scored 8 goals. And you can see the number of goals scored there as a whole. So you want to make sure that you label what you're talking about at the bottom, that your dot plot covers. It starts with the lowest number and ends with the biggest number as well. So again, how to make a dot plot. These are just the tips for you. You want to draw the horizontal axis, a number line. You want to label it with the variable we were talking about, like the number of goals scored. You want to scale it from the minimum to the maximum. Remember, you don't have to draw every number, but make sure there's a line for every number. And you want to mark a dot above the location for each value. So you'll just keep going up with dots if there are more of that number. So how to describe quantitative data. In any graph, look for the overall pattern and if there are departures from that pattern. And when we say to describe a distribution, you are going to use SOCs. So shape, outlier, center, and spread is the nickname for SOCs. So if you'll remember SOCs, if you'll write that down, keep that in your memory. We're going to try to describe, when it asks you to describe a distribution, you want to describe the shape of the distribution, if there are any outliers, the center of the distribution, and the spread. So first, we'll talk about describing shape. When you describe a distribution shape, you want to concentrate on its main features. Is it symmetric? Roughly symmetric is what we're going to call it, or roughly approximately symmetric. Or is there a clear skewness? Is there a clear tail toward in one direction or the other? If you look at this first graph right here, we would call this roughly symmetric because we do not see a tail in any direction. We don't see the data. We just see it. It looks like a normal bell curve is what you would notice there. So roughly symmetric is if the right and left sides are approximately like mirror images of each other. Skewed to the right means that there is a tail to the right. It's much longer on the right side. So it means a lot of your data is on the left and you have a tail going off to the right. Skewed to the left means that there is a long tail over there to the left. So you see a picture of each one. You may want to go ahead and put that in your notes so that you can see roughly symmetric, skewed left, or skewed right. And that's how you're going to describe the shape of a distribution. And you notice a skewed right distribution, the center is a little bit further over to the left, and it has a longer distance to the right. In a skewed left distribution, the center is over there to the right, where the back of her skis are, and then you see is skewed to the left. So you have just a tail over there to the left. And then there are a couple other ways that you may see shape described. Unimodal means you have one mode, which means basically like you have not much data at all to the left and right, and you have one big clump of data in the middle. So like maybe if you went from 0 to 10 goals scored, maybe the team scored 5 goals almost every game. That would be like unimodal. Bimodal means you have two modes. So you have a mode here where there are a lot of things happened, and then a lot of things happened also over here, and then multimodal. And we don't use those very often, but we do if there's like a big gap. So let's say like they scored 2 goals a lot of times, then they scored 8 goals a lot of times, and there's a big gap in between, then we might use something like bimodal. So let's look at our definition for outliers. Our definition is values that differ from the overall pattern. So basically what you're going to look at is numbers that are far away from the others. And we will have a formula to calculate outliers, but that is really what we're looking for, is where is a number that is far away from the other. And you see that's a question mark because we don't know for sure if it is a outlier or not, but we will learn that later on. So that could be that 15 here could be a potential outlier because everything's centered together from 8 to 12, and then suddenly you have a number at 15. How you describe the center? So you can describe the center by finding a value that divides the observations in half, and you can find the center in 2 ways. Whichever one you want to use, you just want to make sure you describe it. You can find the median, and it's best to use the median if you have skewed data. So if you have data that has a long tail to the left or a long tail to the right, you'll use the median. If the data looks to be approximately symmetric, then the mean or the average would be your best use of center. So the mean and the median are your uses of center. And then spread. We have 3 ways to calculate the spread. The spread tells us how much variability there is. So that just tells us, like, how spread out is our data. The range, which would be the maximum minus the minimum. The IQR, which is the 3rd quartile minus the 1st quartile, that can be found in your calculator. And the standard deviation can also be found in your calculator. So all those things can be found by using the calculator function that we'll go over at a later time. And so below, what we're going to find here is a distribution of the miles per gallon by various Honda vehicles. And we're going to describe the shape, center, and spread, and also outliers. So SOX. So think when it says to describe, we want to use shape, outlier, center, and spread. And the first thing I can notice here is that there's a lot of dots over to the right, and I see that the tail is to the left. So the shape seems pretty obvious that it would be skewed left. It looks like, these could be potential outliers. So I'm going to name that as potential outliers. The center, I can count how many dots there are and find the median. And then also the spread would be, we would go to 33, which is our maximum, minus 14, which is our minimum. So look at the sample answer here, and you see that it is skewed left. You see the mean and the median. You only need one, so the median would be fine here. The range is mentioned, which would be 33 minus 14. And then the outliers. There's 2 potential outliers at 14 miles per gallon and 18 miles per gallon because they're both far away from the others. Stem plots are our next type of quantitative graph. So we look at a stem plot, and a stem plot, the stems, you may have heard this called a stem and leaf plot before, but the stems are on the left side and your leaves are on the right. So this is a stem plot with 0, 1, 2, and 3. And basically the 0, 4 stands for the number 4, and the 3, 8 would stand for the number 38. Right, and it tells us in the key what the numbers represent. So you do want to make a key in those. And then the second one, the one on the right, is called a split stem plot. And a split stem plot means you go through the numbers 0 through 4 and then 5 through 9. So like the first stem would be 0 through 4, then 5 through 9, then 10 through 14, then 15 through 19, 20 through 24, 25 through 29, 30 through 34, and 35 through 39. And we do include a stem even if there's no numbers there. So you can't just skip a stem. So for instance, if there was no numbers in the 20s, you still write that stem there to show that there's a gap. So you don't just skip it. If you skip it, then your graph is not going to look correct there. So a couple steps on how to make a stem plot that you just saw. You want to make the stem and leaf. The stem is everything but the final digit. The leaf is the final digit. So if it was a 3-digit number like 104, the 10 would be the stem and the 4 would be the leaf. You write all possible stems from the smallest to the largest. Write each leaf in the row to the right of its stem. You're going to arrange them in increasing order and provide a key, because you could be doing decimals like 2/2 could mean 2.2, or it could mean 22. So here's an example of a stem and leaf plot, and this is the responses of 20 female AP statistics students, and the question was, how many pairs of shoes do you have? So basically, the biggest number in this data set is 57, and the smallest number is 13. So we have stems of 1, 2, 3, 4, and 5 for the 10s, 20s, 30s, 40s, and 50s. And then we have our leaves. And notice they made the leaves, but then you must put them in order. If a number repeats, you do write it more than once, and it goes in increasing order. So this one here on the right is your final stem plot, and there's your key, which tells the person, hey, 4/9 means a female student who has 49 pairs of shoes. All right, so there are two special types of stem plots. There is a split stem plot that we talked about where you split them from 0 to 4 and 5 to 9. There is also a back-to-back stem plot that can compare two separate distributions. So this would be males on the right and how many pairs of shoes they have, and females on the left. And if you notice, they share the stem in the middle, and then their numbers are going in each direction. So you see that's called a back-to-back stem plot. And finally, our last type of graph that we're really going to look at in detail is a histogram. Histogram looks similar to a bar graph, but a bar graph is only for categorical data. And so a bar graph, you always have a space in between your bars. A histogram, there is no space. They connect to each other. And if you notice, there is numerical or numbered data at the bottom. So that would be 250, 255, 260, 265, 270, and then the numbers in between there. Most common graph, when you have one set of numerical data, this is the most common graph that you'll see is a histogram. And it's very clear to see, which group is higher or lower. So how you make a histogram, you look at the range of your data. What's the maximum? What's the minimum? If the maximum is 45 and the minimum's 15, then that would be a range of 30. So if you want 6 bars, then you make them 5 each, right? So if you're going to have 30, then you would make each one be 5 numbers each. And you're going to find the frequency, which means how many times it occurs, or the relative frequency of what percent it occurs there. And then you will want to always label and draw your scale. So for instance, here is a example of a histogram. This would be numbers from 0 to 30. So if you notice, there were 20 that were between 0 and 5. There were 13 from 5 all the way up to 10. There were 9 from 10 all the way up to 15. There were 5 from 15 all the way up to 20. There were 2 from 20 to all the way up to 25. And there was just 1 from 25 to 30. And that makes 50 total states, right? And this is their percent of foreign-born residents. So you can notice that we know that 20 states have from 0 to 5%, and we can easily see that 5 states have from 15 to 20%. So that will help you if you want to go back and see how you would make a histogram. So don't confuse a histogram and a bar graph. So know the difference between a histogram and a bar graph. Histogram is for quantitative, which is numerical data. Bar graph is for categorical. Don't use counts or percents as data. So again, you don't want to just have the table and not have the histogram. And a lot of times on the vertical axis, if you're comparing two distributions, you want to use the percent because they each might have a different total number as you go up there. And just because a graph looks nice, it says it's not necessarily meaningful. So you want to make sure that your graph is accurate. So below there is a check your understanding that I would like for you to complete. So if you will pause the video right now and check your understanding on this dot plot. And now that you've checked your understanding, we'll go through the answers. So what percentage of students scored higher than 16 points? We count up the dots and we see there's 17 dots that are higher than 16 out of the 21 total students, which is, if we change that to a decimal, 0.8095. So that would be 80.95%. Describing the shape of this distribution, there's clearly a tail to the left, so it is skewed left. And are there any potential outliers? So we see this student way out here at a 10. That would be an outlier. They performed much worse than the rest of the class. If you look, here are some AP stats scores by percentage. You see some dot plots, the percent of students that scored a 5 on the AP stats exam, the percent of students that scored a 4, percent of students that scored a 3, which 3, 4, or 5 are passing, percent of students that scored a 2, and then the percent of students that scored a 1. So when you compare, you want to use the words bigger, smaller, greater, less than, similar to, about the same, almost equal, etc. You want to make sure you cite the actual numbers. So like say the numbers, be specific, talk in the context of the problem, and always include at least 2 areas of comparison. So here is something to compare. So this is a back-to-back stem plot. We see 19 middle school students and we see their resting pulse rates when they're just sitting down. We also see their pulse rates after they've done 5 minutes of running. And I want you to write a few sentences comparing these distributions. Remember, you can think about the shape, outlier, center, and spread when you go through this. So pause the video and write a few sentences about these. Okay, now that you've done that, notice the resting and after exercise pulse rates are both skewed to the right. You may have thought the resting one was skewed left, but think about it on a number line. The bigger numbers like 120 and 104 are the tail, and that tail would be to the right if we kind of took that stem plot and put it on a number line. So they are both skewed to the right. Their tail is towards the larger numbers. The median for a resting pulse is lower than that for exercise. It has a median of 76, where the exercise has a median of 98. The variabilities, meaning the range, is fairly similar. The resting range is 52. It's 120 minus 68, whereas the exercise range is 60. It's 146 minus 86. And there is one potential outlier in both distributions. So in the resting heart rate, there's 120 beats. That's an outlier. And in the after exercise heart rate, there's one at 146. That would be an outlier. So hopefully today this got us through kind of graphing and looking at quantitative data. So we went over stem plots, dot plots, and histograms briefly, and we'll talk through this some more and have some assignments to follow. Thank you.